Hello, and welcome to this set of problems on complex numbers. So this is the 22nd set. We will solve problem number 211 to 220 in this set. So without further ado, let's get started. As always, I will repeat that when I am stating the problem, you should pause the video and try to solve the problem yourself. Look at the solution if you cannot solve the problem, but first give it a good try. So let's get started. Problem 211 says that solve the equation z square plus z mod z plus mod z square is equal to 0. So clearly z is equal to 0 will be one of the solutions of the given equation. Now what we do is we divide the entire equation with mod z square. So this will make the equation t square plus t plus 1 is equal to 0, where t would be z by mod z. Now we know that from our cube root of unity equation, t square plus t plus 1 will have two roots, omega and omega square, which means z by mod z is equal to omega and omega square. This gives us two more values for z, that is kw and k omega and k omega square, where k will be mod z, which is a non-negative real number. Problem 212 says that solve the equation 2z is equal to mod z plus 2y in complex number. So we let z is equal to x plus iy. So left hand side will become 2x plus 2iy and right hand side will be square root of x square plus y square is plus 2y. Now we compare real and imaginary parts. So first we compare imaginary parts. 2y is equal to 2. That means y is equal to 1. Now we compare the real part. We have 2x is equal to square root of x square plus y square. We square both sides. It will be 4x square left hand side. And right hand side will be x square plus y square. But y is equal to 1. So y square will be 1. That means 3x square is equal to 1. So x is equal to plus minus 1 by root 3. So we have the solution as z is equal to plus minus 1 by root 3 plus I. Problem 213 says that if a greater than 0 and z mod z into mod z plus az plus 1 is equal to 0, show that z is a negative real number. So as always, we let z is equal to x plus iy. Our given equation becomes x plus iy into square root of x square plus y square plus a x plus iy plus 1. Now we compare the real and imaginary parts. So comparing the imaginary part, we will have y into square root of x square plus y square plus ay is equal to 0. So one of the solutions would be y is equal to 0. The second solution would be square root of x square plus y square plus a, which would be not equal to 0 because a is greater than 0. And this is mod z, which would be always positive. Now the real part comparison would give us x into square root of x square plus y square. Now y square is 0 plus ax plus 1. So what we have is here we take out x from the square root, we have x square plus ax plus 1 is equal to 0. So x would be minus a plus minus square root of a square minus 4. Now you see that square root of a square minus 4 would be less than a. So both the values would be negative. So y is 0 and x is negative. That means our z is a negative real number. Problem 214 says that for every real number a greater than 0, find the complex numbers find the complex numbers z satisfying the equation z mod z plus az plus I is equal to 0. So this is like previous problem. Again we have this equation and we compare the real and imaginary parts. So instead of 1 we have I. So the answers will flip. This time x will become 0 and y will become a negative number. This would be a purely imaginary number. I mean z would be a purely imaginary complex number. Imaginary complex number is a bit a tongue twister. You can simply call it purely imaginary number, which will have negative coefficient. Question 215 says that for every, there is a typing mistake here. For every real number a greater than 0, determine the complex numbers z, which will satisfy the equation mod z square minus 2iz plus 2a into 1 plus I is equal to 0. So we again put z is equal to x plus iy, and our equation becomes x square plus y square minus 2 into x plus y plus 2a into 1 plus I. Now we compare the real part first. So we will have x square plus y square plus 2y plus 2a is equal to 0, which gives us x square plus y minus 1 whole square is equal to 1 minus 2a. Okay. On the imaginary side, we will have minus 2x plus 2a equal to 0. So x is equal to a. Now we substitute this a, x is equal to a in this. So this will become y minus 1 whole square is equal to 1 minus 2a minus a square. That is, y is equal to 1 plus minus square root of 1 minus 2a minus a square. Now 1 minus 2a minus a square would be greater than 0. Why this would be greater than 0 is because a is a real number. Okay? So this has to be greater than 0. So because from this condition we find this a to be minus 1 plus minus root 2. Okay, from this equivalent quadratic equation we find minus 1 plus minus square root of 2 are the roots of for a, and our coefficient of a square is negative. Okay, so since a is greater than 0, the range for a would be, it has to be greater than 0 first part, and second is it has to be less than square root of 2 minus 1. This requires a bit of knowledge on quadratic equation, which we have not studied. So it mixes two concepts, complex numbers and sign of quadratic expressions and equations. So if you do not understand this concept fully, then please wait till you have studied quadratic equations and then you can come back to this. Question 216 says that if alpha and beta are two complex numbers, so that mod alpha plus beta whole square plus mod alpha square plus mod beta square plus real part of alpha beta bar plus real part of alpha bar beta. So in this case, we take alpha as a plus ib and beta as c plus id. Now clearly alpha plus beta mod square will be a plus c whole square plus b plus d whole square. Now alpha square is a square plus b square, and b mod alpha square, that is mod beta square, is equal to c square plus d square. Now we try to find out real part of alpha beta bar. So this will become real part of a plus ib into c minus id. Now we multiply and you will find the real part as ac plus bd. And similarly, the real part of alpha bar beta would be ac plus bd. So both are same. So now clearly we will have 2ac plus 2bd. So 2ac we will add with c square and a square. That will become a plus c whole square. And 2bd we will add with b square and d square. So that will become b plus d whole square. Therefore, the given equation which we have to prove is proved. Question 217 says that find the integral solution of the equation 3 plus 4i to the power x is equal to 5 to the power x by 2. So we let z is equal to 3 plus 4i. Now mod z is 5. The given equations become z to the power x is equal to mod z to the power x by 2. So we square both sides. We have z to the power 2x is equal to mod z to the power x. Now what we do is we write here z to the power 2x. So z to the power 2x is 3 plus 4i to the power 2 to the power x. And we bring mod z to left hand side. So we divide by 5, and 5 is raised to the power x. That is equal to 1. Now 3 plus 4i whole square is 3 minus 16 plus 24i by 5. Now this whole to the power x. Now this becomes minus 7. Okay, so 16 minus 3 should be 13. 3 is 9. This should be 9. This is not 3. 9 minus 16 is minus 7 plus 24i by 5 to the power x. Now this is possible only if x is equal to 0. Question 218 says that find the integral solution of the equation 1 minus I to the power x is equal to 2 to the power x. So, studying like previous problem, we have 1 minus I by 2 to the power x is equal to 1, which is possible only if x is equal to 0. Question 219 says that find the integral solution of the equation 1 minus I to the power x is equal to 1 plus I to the power x. So what we do is we write it as 1 minus I by 1 plus I to the power x is equal to 1. This becomes minus 2I by 2 to the power x, this is minus I to the power x. So for this to be 1, x has to be a multiple of 4, where in this case we have written it as 4n, and n is in the set of integers. Question 220 says that prove that mod of 1 minus z1 bar z2 squared minus mod of z1 minus z2 squared is equal to 1 minus mod z1 square into 1 minus mod z2 square. So we take left hand side, we have mod of 1 minus z1 bar z2 squared minus z1 minus z2 mod z1 minus z2 square. So we expand this, and we know that if there is mod z square, then that is equal to z bar. So left hand side, when expanded, becomes 1 minus z1 bar z2 bar into 1 minus z1 z2 bar minus z1 minus z2 into z1 bar minus z2 bar. This is the identity which is used here. Now we multiply this, and it becomes 1 minus z1 bar z2 minus z1 z2 bar plus z1 mod z1 square mod z2 square minus mod z1 square minus z1 bar z2 minus z2 bar plus mod z2 square. So when we take this here, it cancels out this z1 bar z2 from here. This will be positive because minus minus plus. And similarly, z1 z2 bar will be cancelled. So our equation becomes 1 minus mod z1 square minus mod z2 square plus mod z1 square into mod z2 square. This is equal to 1 minus mod z1 square into 1 minus mod z2 square. So with this, we come to the end of our 22nd set of problems on complex number. I hope that you have found this video, find this video useful and informative. Please subscribe to the channel and like the video. That's the thing every YouTuber says, because it does two things really. I mean, every YouTuber says it not only for think in terms of money. It's not only about money. It is more of a motivation. If you watch the video, you like the video, you engage in comments, then it motivates us to make more such videos. Second thing which happens is because of YouTube algorithm, the reach of the video will increase if you interact with it in any form, like subscribing to the channel or commenting or sharing it on social media. So it will increase the reach also, because that's how YouTube works. So please subscribe, comment, share. In comment, let me know what improvement I can make on the videos, or if you want videos on any specific topic, let me know. For 12th standard, I can possibly make videos on physics and chemistry, but I will not take up physics chemistry right now. First, I have to cover the maths part of it. So thanks a lot for watching. Have a nice day.